Hello, my name is Robert Messina. I host the website bethasher.com, which is basically a site that points to YouTube videos that I have been doing. I've been putting them up there ever since I think 2007. And my latest video was How Far the Stars. And in that video, I take a big portion of the beginning to let us all grasp the idea of the six-day creation and how much time that we know of, that we use today, like a day is 24 hours, how much of those time days, how long were they in the creation week? Because the creation week is separate from the earth that we live in right now, in a sense. And I talk about how if you look closely at Genesis, we're still in the sixth day now, and it hasn't finished yet, and God has not rested with us yet, and that's all. I don't want to take 15 minutes of this video for that. Just watch that one. This is essentially part two of the battle that a Christian or a believer in God has, a believer that believes that the Bible is given to us by God, and how there is another book out there, and I'm going to call it the Cosmology Text Book, whatever. There must be hundreds of them, I don't know. But those books, the way they talk about how things are and what we see, such as the stars and how far away they are, and that they are billions of light years away in 6 days. Okay, there's so 6 days, but I think that the stars were made about 50,000 years ago. 24,000 years for each creation day. This is the sixth day, almost over. So that's about, and they made the star. He made the stars on the fourth day. So it's about 50,000 years ago that the stars were shining upon the earth, and that's a big difference between billions of light years. 50,000 and billions are very, very distant apart numbers. Okay? So there's a problem here. There is a problem. There's a disagreement here. There's beliefs in one and beliefs in the other. And it isn't science. It's not science that you're saying, well, it's science telling you. I'm sorry, a man is telling you that, not science. A man is telling you that, and you're believing him. And I believed them too, for a lot of things they said. I believed it too. We all get caught in this trap of believing what the academic authority tells us. And that's why this is volume 2. And I hope I don't have to go to volume 3, but I might. Because there's so much information. There's so much information that I'm going to start talking about it. So before I start talking about it, I do always like to pray or pronounce, declare, not so much pray, but declare light on the subject with these words. Vayomer Elohim Yehi Or Va Yehi Or. Okay, that just shed light on this subject. And so, believe it or not, it works. It sort of like opens understanding between the speaker and the hearer. So I said I was about to talk about it now. Where could I start? And I think a good place to start is the book of Genesis, the very first verse. Because I don't know what the Cosmology Text Book says in its beginning sentence, But I bet you it can't, it doesn't hold a candle to this brightness of the first verse in the Bible, the very first verse. It's actually, to me, it's the heading. It's the heading. It's the title of the book. To me, it's the title of the book. Okay. Bereshit bara Elohim et hashamayim ve'et ha'eretz. In the beginning, Elohim created the heavens and the earth. Okay, now all of those, you see the numbers above the letters there in Hebrew. I'm just going to just show you, I mean, you're trying to outdo this book, and this book is given to us by God who made everything? You're going to try to outdo him and say he's wrong? I'm sorry that this is where the fight begins. This book is contradicted by the Cosmology Text Book. All right? And all of the scientists that write in there, they don't believe in this book. Or they don't believe in this God. Our God, my God. The God who made it all. The God who did it all. The God who does it all. And is still doing it. Okay, so there's this fight. Now, guess who's going to win? Who's going to win the fight? You tell me. You tell me. The guy who never made anything in his life, never spoke anything in existence in his life, the only thing he speaks into existence is a big fat lie. 4.5 billion years ago, the solar system started. That's the big fat lie that he speaks. Okay? Where does he get it from? He wasn't there. He doesn't really know exactly. He's theorizing it. It's a theory. Don't say it's fact. It's a theory. Because he wasn't there. But the one who wrote this book, who wrote these words, was there. Now, I got the numbers up there. I just want to give you some idea about those numbers. There was a guy named Ivan Panin. He wrote more than 42,000 pages of Bible gematria notes. And he found over 50 multiples of 7 in the very first verse. In that verse, 50 multitudes of 7. Now, the 7 words, first of all, there's 7 words. And in the first verse, it has exactly 28 letters, which is 7 times 4. Now, the gematria of the first and last letters of the first half of the verse is 42. That's 7 times 6. The gematria value of the first and last letters of the second half of the verse is 91, and that's 7 times 13. So, first of all, you have 42. And Matthew has 42 generations from Abraham to Mashiach, Jesus. And 42 is 7 times 6, and 7 is a satisfied number of God, and 6 is the last day that man has to work before he rests. So it's a number of man, number of God, number of man, number of God. Okay, that's 42, 7 times 6. And that's describing the Son of Man. He's Son of Man, and he's Son of God. Okay? So right there you have the number 42, and it's a multiple of 7. Then you also have the number 13, and 13 is 7 plus 6. So you have the Son of Man, Son of God in the first half, and he's in the second half too, and it's got the multiples of 7 in both of them. Now the nouns have 14 letters, and that's 7 times 2. The sum of the nouns, God, heavens, and earth, is 777. That's 7 times 111. The place value of these nouns is 147, which is 7 times 21. 21 is 3 times 7. The Hebrew verb created has a value of 203, which is 7 times 29. The first 3 words contain the subject and have exactly 14 letters. The first three words is the subject and have exactly 14 letters. That's 7 times 2, of course. The place value of these letters is 140. That's 7 times 20. Of these 14, the place value of the silent letters is 28. That's 7 times 4. And the place value of the non-silent letters is 112, and that's 7 times 16. The odd numbers among them, of the 14, total 42. That's the odd numbers, 42. And even numbers among them total 14, total 98, which is 7 times 14. So you see, the odd numbers, that's Son of God, Son of Man. The even numbers are God, God, God. That's 7 times 14 is 7 times 7 plus 7. God, God, God. Now, multiplying the 14 place values of the letters by their order is 7 times 144. 144 is 12 times 12, which is another biblical number. The last four words contain the object and also have exactly, the last four words contain the object. Now, the subject and the object in the sentence, the object is the heavens and the earth, have exactly 14 letters, okay? Well, we divided into two pieces, 28, divided into twice is 14. Okay. The object, the heavens, has 7 letters, as does the object and the earth, 7 letters. So it's the heavens and the earth. The heavens is 7, and the earth is 7. The numeric value of the first and last letters of all words is, the first and last letters is 7 times 199. The sum of the first and last letters of the first and last word is 497, 7 times 71. The value of the first and last letters of each word between is 896, 7 times 128. Sum of the factors of 896 is 21, 7 times 3. The first letters of the first and last words have a gematria of 7. The gematria of the last letters of the first and last words is 490. That's 7 times 70. The middle word and the one before it have together 7 letters. The middle word and the one after it have 7 letters. The value of the first, middle, and last letters in the sentence is 133, which is 7 times 19. Now, this guy, this is just a piece of the list. He wrote 50 pieces in this thing, and we don't have time to go over them all. You're already getting tired of hearing how many 7s there is in this thing. But it's there. It's all there. I mean, look at it. Look at it. I mean, nobody's. This aleph is the first letter of the alphabet. Alphabet. Aleph is the first letter. Okay, and then hey is the 5th letter. Bet is the 2nd letter. And it's all in there. You know, nobody's making this up. By the way, just to let you know, this et here, it doesn't really mean the. The ha, shemaim, is the. The is really the ha. The et has absolutely no translation into English. It's there. It's there, though. Et. And that's the first and last letter of the alphabet. Okay? It's the first and the last letter. He's the first and the last. The first and the last is in the creation of Hashemayim, and the first and the last is in the creation of Haaretz. Hashemayim is his throne. Haaretz is his footstool. So the earth is very, very special in this book. It's more special than any of the planets or the stars or the sun or the moon that are created on the 4th day. This was created on the 3rd day. Now, I just apologize to all those people out there that already got it, that this book is very inspired, and that it just doesn't come out by chance. A lot of you's already got it. But I want to let people know that this is not the only amazing thing with words and letters and gematria. I mean, there's thousands of amazing things like that. Now, I'm just going to include two examples. They have to do with the Hebrew names for frequencies and the Hebrew names for sun, earth, and moon. Okay? So, this guy from Ben Gurion University of the Negev, Professor Chaim Shor, he stumbled upon a certain amazing thing that the Hebrew word for the color matches the color's wave frequency. Okay? His methodology was relatively simple. He took Hebrew names of 5 colors that appear in the Bible: red, Adam; yellow, Zahav; green, Yerachon; blue, Tselet; and purple or magenta, Argamon. And he calculated a numerical value for each word by adding the total values of the letters, with aleph as 1, bet as 2, like we were just doing. Then he plots them on a graph. The vertical axis charts the colors, waves, frequency, which are scientifically established, while along with the horizontal axis, the CNV, color name value, appeared. When it was complete, the man was astonished. The 5 points on the graph formed a straight line, which means that the names of the colors related directly to their established wave frequencies. It was straight out of statistical analysis, Shor said. I didn't manipulate a single number in doing the analysis. He's going to go now to the moon, Yereach, the earth, Eretz, and the sun, Shemesh. And one thing that distinguishes the 3 bodies is their size expressed by the diameters. He uses the diameters as listed by NASA and plots them on a graph just as he did with the colors. On the horizontal axis is the numerical value of the Hebrew word. On the vertical axis is the planetary diameters from NASA on a log scale. He continues. To his astonishment, the phenomenon repeated itself. The 3 points aligned themselves on a straight line. An exact mathematical relationship would have given a linear correlation of 1, whereas these 3 points had a linear correlation of 0.999. What an amazing coincidence. See, I mean, even the colors, the Hebrew word for the color, has within it what its wavelength is. And the Hebrew word for the moon and the sun and the earth have the differences of their size within it, within their name. If you look into the Cosmology Text Books, I don't know where exactly it is in that book, but it's, if you ask the question, why does the earth spin? The answer to that is the earth spins because of the way it was formed. Our solar system formed about 4.6 billion years ago, when a huge cloud of dust, gas and dust, started to collapse under its own gravity. As the cloud collapsed, it started to spin. Now, does that make sense to you? Gas, first of all, gas and dust. Since when does gas and dust collapse upon each other and form so a molten iron core? The molten iron core in the core of the earth, and it's spinning. Not only does it collapse into itself, it spins, and it goes into orbit around the sun that also formed that way. Now the sun is bigger and heavier, in order to have the heliocentric model, you have to have this thing spinning. You have to have the Earth spinning in order to get the 24-hour day and night that you see. And you have to have it orbiting the sun in a tilt on its axis in order for you to get the seasons. Now, the way that we say it, the Earth stands still, and it's in the center of gravity. There are stars above, stars on both sides, stars underneath, stars on both sides underneath. It's in a huge shell of stars. Not to mention, he makes the stars 14.5 billion years before the man sees them. And the man only sees them for 6,000 years. And he's about to fold everything up, throw it away, let it all burn in fervent heat. And we're going to get a new heaven and a new earth. And some of us are going to stay with him. Now, does that make sense? Does that make sense that he has the stars burning for 14.5 billion years before he lets the man look at them? He didn't make them for anybody else. Those stars that have weight and have gravity, that have push and pull with us, and push and pull, there's push and pull, and there's electrical pushes and pulls too. Yeah, but in our model, the Earth is still, it's in the center of gravity, it's in this big shell, and it can't be moved, just like it says. It says it can't be moved. This book says it can't be moved. Now, the other book says that it does move. It moves very, very rapidly, orbiting the sun at 30 kilometers per second, or 67,000 miles per hour. That's the Earth orbit around the sun speed, which is 64.5 times faster than the Earth spins. And the Earth spins at 1,675 kilometers an hour, or that's 465 meters a second. Now go ahead. Go 465 meters every second. And sometimes those two speeds add of how fast we're going. Sometimes they don't add. That's what the other book says, that it does move. And it can be moved, and it does move. So there's a difference. You see the difference? One is made along with the sun, the same time frame as the sun is made, as all the stars are made, as everything is made. It's in the same time frame. And the other book says, oh, it was made a day earlier. Now, if it's made a day earlier, did he start it spinning? Did he start it orbiting and then put a sun in the center of the orbit? I mean, tell me how that actually happened. And you give me the dynamics of it. I mean, you're going to have to come up with it. I'm not saying it spins in orbits. You do. And you're going to have to explain. Now, before we get into explanations, I think it's amazing that there's something that they say, and Einstein said it, Ernst Mach. Einstein got it from Ernst Mach, the scientist that Einstein knew and got information from. So Ernst Mach said it, and Einstein repeated it. And Einstein has been repeating everybody else's stuff his whole career. I used to really like Einstein. I used to look up to that guy. I don't anymore. All he was he's just a fake. You have to the information is all out there. But Einstein and Fred Boyle, that's the quote that I got. I got a quote by Fred Boyle, and it's in here. Sir Fred Hoyle. He says, we know that the difference between the heliocentric theory and the geocentric theory is one of relative motion only, and that such a difference has no physical significance. So he's saying that either model that you take, it's going to explain what you see. And the no physical significance, I don't go along with that, because I think there is a physical significance. I think there is a difference between the two of them, a physical difference between the two of them, and one is true and one isn't. But it's amazing that whatever you say to try to counteract the other one will come up and say, "But yes, it could be explained like this." Um, for example, they try to say there's no aberration, no stellar aberration in the geocentric view, and there is, and the focal pendulum. Oh, look, that it was supposed to be proof that the heliocentric model is right. Where this pendulum they have a big setup in the cathedral in France, and they have one out in the West Coast too. And it's like a museum type thing. You go in there and you see this thing going and going, and you see how during the day it goes to a different spot. It rotates around, and they're saying it's rotating because the ground underneath the is moving, and the pendulum is responding to that motion. And that would be true in the heliocentric model. Now, it's also could be explained in geocentric model in that the geocentric model, remember, all of the stars orbit the Earth every single day and night. 24 hours, they're orbiting. And that orbit, they have a massive pull on the gravitational pull on the Earth as well. And this pendulum, which is suspended, is getting affected by that rotation of those. And so it's explained in both models, okay? Now, I think it's interesting that there is an anomaly during a solar eclipse in a number of cases, number of times. They have seen a difference in the pendulum affected by what seemed to be affected by the eclipse itself. Now notice that sort of like leans to the geocentric model, because the geocentric model is talking about the movement of the pendulum is being affected by a gravitational force. Now when you have a solar eclipse, you have the Earth, the Moon, and the Sun, and then the stars. So everything is one-sided in that case. So that anomaly, it's called the Allais anomaly. And there are a number of sightings that number of times that this was noticed and recorded. I'm just going to say that there is this little glitch that you have that favors the geocentric view. So the big proof of the focal pendulum proving heliocentric is actually proving the other one. But again, the amazing thing is, no matter what is said on either case, the other guy is going to say something. Now, for example, I say, look at you take a plane and you go from the West Coast to the East Coast. So New York is coming towards you and you're going towards New York. All right? New York is coming towards you and you're going towards New York. You should get there quicker. All right? Now, you go from New York to California, and California is going away from you, and your plane, you should get there longer. Well, you do cross time barriers, and you got to allow for the time zones, but the time zone isn't time in the air. It's only time zone difference. It's not time in the air difference. So, what does the heliocentric say about that? Well, the plane takes off. Well, before the plane took off, it was going at the speed of the Earth, and now that it's taken off, it's going at that speed plus whatever speed it uses from its jets. So it's the speed of the Earth plus, and then the other way is the speed of the Earth minus. And so whatever differences that the Earth is doing, it just gets canceled out in the sense that it was always going that speed. However, I don't think they have a logical answer for a plane that's on the North Pole that comes down straight down one of the longitudinal lines of the Earth, and he will not have to adjust east or west if he wants because of the Earth spinning. He just has to go straight down the line. He'll go to the place where he wants to go. He will not have to compensate for the spin of the Earth. That's just one that they can't answer. Another one is that goes along with it. Is I sit outside, I look up, and I see a cloud, a big puffy cloud, right over my head, and it's just standing there. It's just sitting there. And meantime, we're going how fast? We're going 1,000 miles an hour if it was the equator. Okay, a little slower from where I am in the north a little bit. Plus, the Earth is moving at 67,000 miles an hour. The Earth is moving that fast, and that cloud is just sitting up there, just hanging like so slow and so little relative motion. I mean, I don't see how it could be. And what do they say? They say that the atmosphere spins along with it. Now, here is where we differ. This is where we differ. The atmosphere goes along with it. Now, I can understand. I got my pickup, right? I sit in my pickup, and I start out at 0, and I turn the engine on, and I go, and before you know it, I'm 50, 60 miles an hour on the highway. Okay? I'm 50, 60 miles an hour on the highway, and all of the air that I breathe is going 50, 60 miles an hour, and I'm going 50, 60 miles an hour. And I got a seatbelt on because if I stopped, I'd go forward, and it would push me right through the window. So I understand that, that an object that is moving, everything within that's contained in that object is moving as with it. And so the speed of the Earth, if the Earth was moving, I'm standing on the Earth, I'm moving along with that thing too. But here's where, you see, I told you about the air in my cab is also moving that fast, and I agree with that. But guess what? The air that was before I started up, that was in the back of my truck, my pickup truck, that air is not there no more. And it is not. As soon as I took off, that air immediately left. And it was not going with me. And the air, you see, you're saying that the Earth spins. Now, the Earth has a surface. And the surface of the Earth, okay, you're saying the surface of the Earth spins. In order for you to get the cloud above moving, you have to say that the cloud above is moving as well. And there's where we have a problem, because in my cab, there's a top. All of the air is contained within the cab. The air that's on the surface of my truck on the back has no container. And because it's light, now I can have a heavy object on the back of that truck and it won't move because it's heavy. It's got gravity and it's pulling it down. But air hasn't got the same gravitational pull that the rock has in the back of my truck. You see? Or the rock that's on top of the Earth. I can understand if it was spinning, the rock on top of the Earth would spin with it. But the cloud above me, that light puffy cloud, is going to spin with it too? Oh, well, now you're going to have to come up with some better explanation, because I don't buy it. I'm not buying that one. You can say it, and when does it stop? What point in the atmosphere does it stop spinning? You're telling me that the the helium atom that's way, 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 way up there because it's so light. That helium atom is spinning and has to go the fastest. That one has to go the fastest because it's got the most diameter. It's up there the furthest. That has to go a lot faster than the surface of the Earth if it's up there. It's that far up. Because the bigger the diameter of the wheel goes the fastest. The spokes, inside the spokes, it goes the slowest. It's the big diameter way up on the top of the wheel that goes the fastest. So that helium atom has to go the fastest. I'm sorry, I don't believe it. I don't buy it. It's not happening. All right? There's where you have a problem. And there is a physical difference. It has no physical significance. It does. It does have a physical significance difference, and that's one of them. Where you say it stops, because the guy flying the plane, okay, he started out with, and he had, if the Earth was moving, he'd have the speed of the Earth with him. But when he ejects, the speed of the plane goes forward, and he doesn't go forward. He goes forward a little bit, and then he stops, and then he slides down, and he parachutes down, straight down. Well, okay, let's talk. The wind takes him. If there's no wind, he'd go straight down. And the guy who jumped, he came straight down. He came straight down. And if the Earth was spinning, it wouldn't have came straight down to the spot. He would have moved. All right? So there's a difference. Now, let's talk about orbit, the geometry or the forces that are required in an orbit. Now, you're telling me that the Earth is orbiting the sun, right? That's what you're saying. The Earth is orbiting the sun. A huge, tremendous orbit. And it has to go around this huge, tremendous orbit. And it has to take a year. So it's got to go pretty fast. 67,000 miles an hour? In order for that orbit to happen, it has to be a perfect balance between the mass of the Earth and the mass of the sun, because that's the gravitational pull to go inward towards the sun. It has to be pulled towards the sun. That's one of the forces that has to happen. It has to be pulled towards the sun. And that pull has to be balanced, perfectly balanced, with the velocity of the Earth going in a forward direction. Now, that velocity of Earth in that forward direction has to be just so that it causes a curve. The pull of the Earth and the velocity and its momentum in the forward direction, they pull each other, and you get a compromise, and it starts to orbit. And that's the mechanics of it. Okay? That's the mechanics of it, which had to be amazing that even happened. And now you also are spinning. Now you also are spinning, and the spin is tilted. The spin is tilted 23.5 degrees from the way you're going. Now, the very fact that you're spinning, it means that you're causing a gyroscopic torque. In this case, it's in the south direction, and it's in the south. It's not straight south. It's 23 degrees south, and the very fact that you have that torque pulling it down is going to pull that thing right out of orbit. It's not going to have an orbit. An object that spins like that is almost impossible to orbit. It's impossible to orbit. I'm just going to say it's impossible to orbit, because you can just look at what you see here. You see the object spinning, and it's a gyroscopic force pushing it in in this case the downward direction, you try to move it, and guess what? It doesn't want to move. It goes up or it goes down, but it does not want to move in the direction which way you're pushing it. So the force going forward gets nullified. But you got to have a force going forward in order to get an orbit. Now what are you going to do? Look at there's a gravitational pull coming down, pulling this thing down, but because it's spinning, it's not going down. When you stop it spinning, it goes down. Okay? So you got something, you got to have it spinning, because otherwise you wouldn't have 24 hours, 12 hours in the day and 12 hours in the night. You got to have that thing spinning in your model. We don't have to have it spinning. We could just say that the sun orbits us, which is what it does. Now, you got this thing spinning. I'm going to have a thought experiment here. I'm going to say it's a thought experiment because I'm not going to the North Pole. But if you took, and you don't even doesn't even have to be a North Pole. You can do it out of your house. I'm still not doing it. I don't feel like doing it because it's ridiculous. You put the telescope on the North Pole, and you put it straight up and down, and you're going to see in the telescope, you're going to see Polaris, the North Star. Okay? That's the one in time-lapse photography during the night hours. You see all of the rest of the stars in the sphere rotating around it. But that one doesn't rotate. That one stays still because it's straight up north. Okay? It's at the top of the universe, you might say. 6 months later, you can look at that telescope, and you're still going to see the North Star. And you didn't move the telescope. It's frozen. You can't move it anyway. All the ice went around it. But you should not have to move it and see the one that's right above us, directly north above our Earth. You don't, from day in to day out, it's the rest of the stars that move basically a degree a day. Every 24 hours it moves they shift another degree for a whole year. And when a whole year comes by, phew, bump, there they are, they're starting over again in their story that they give us through the constellations. There's a tremendous story, and that's on my website. Because God made the stars and the heavenly, He made the heavenly lights to be for signs and for seasons, and those signs are telling us a story, very important story. You should know it. Anyway, so every day there's a degree of the circle is attained by the stars going around. And that's why you see them in different times of the year. You see them in different places in the sky. But in the heliocentric model, how do you explain how that telescope pointing to the North Star in the summer is still going to point to the North Star in the winter? I mean, it's 186 million miles away. You just moved that telescope 186 million miles away, and you think you're going to see the same star? Okay. Well, I don't think so. But you know what? You will. I'm not going up there, and you could try it. You don't even have to go up there. You can just point it to that star where you are, and 6 months later look at it. Don't move the telescope. Don't do nothing. 6 months later, you're still going to see it there. You don't really have to go on the North Pole, but I'm just saying that the North Pole is right on its axis, pointing right to it. What about the magnetic field that surrounds the Earth? What about that one? It has a North Pole and a South. By the way, the North Pole is on the south. Magnetically, it's the South Pole that has. It's hard to explain, but the North Pole of the compass, the magnet of the compass, the North Pole of the magnet, was always attracted to the north, which was actually the south. I mean, they do things the way I do it, all mixed up. But anyway, the north, the magnetic field. Now you're saying that Earth spins, and that creates this magnetic field. Well, first of all, the magnetic North Pole is not the true north of the spin. What you say is the spin. It's 11 degrees off. Now, when did you ever create an electromagnet and the North Pole, the north of that magnet, was 11 degrees off? You never did. Whatever the spinning of the electrons goes, it's straight up and down. It's not 11 degrees off. So that's telling you it's not spinning. Because probably would. I mean, you got this iron core and it's spinning and it has got to have some motion, and there's got to be a little slush going around. I mean, come on. And it's just got to have something to do with the magnet. But how is the magnet? How do I think the magnet happens? The magnetic field is created through the aurora of the North Pole, and there's aurora on the south. There's an aurora on both sides, and the aurora is generated by what they call Birkeland currents, because there was an astronomer named Birkeland who was a Norwegian that was just thrilled about the aurora, and his whole life he was studying it, and he came up with why the aurora is an aurora, and it's the idea that the aurora is just a plasma gas, which is what is out there in the stars as well. Everything is plasma gas all throughout the whole universe that are electrically connected with these Birkeland currents, where you have positive ions going one way and you have electrons going another way, and these things twist around each other, and they're called they're filaments that go through planets and our planet as well. And this whole subject is EU, electric universe. It's mostly, most of the knowledge is coming through what's called the Thunderbolt Project, and some of the two top scientists are Dr. Donald Scott and Dr. I'm going to call him Dr. Wallace Thornhill, okay? And then there's others that have to talk about and speak about it and stuff, but these are the guys that are, they're getting up there in age like we all are, and somebody's going to have to carry on with this, and I can't let it go to the wayside, because what they say does not go into that cosmology textbook, okay? In the cosmology textbook about the sun, you have the core of the sun, a nuclear fission reactor, creating all this heat and creating the light and the heat that we get from the sun. Meantime, the surface of the sun is cooler, a lot, like 100 times cooler than above it. But it's a lot cooler than the above the surface of the sun. So how does that happen? I mean, that doesn't happen. It doesn't happen where you have a firebox and the convection comes out. And the hottest spot of a firebox is always the surface of it. And above that, it gets hot. It's hot, but it's cooler than the you burn yourself if you touch the surface. You don't burn yourself if you're just near it. Well, that's not the case in the sun. You're going to burn yourself if you're near it, and you won't burn yourself when you touch it. So it's not a fire in the middle. So what is it? It's electricity going through it. It's like a light bulb. Really, it's like a big, fat light bulb. And you wouldn't be surprised. You would be surprised as to what's fueling this light bulb, which is the greater light to rule the day. As Genesis says, the greater light to rule the day. It's almost like the entire universe is providing the the electric power to it. And you can look at this diagram here. This diagram shows the sources of the electric currents that's coming through this thing on both sides. Okay, for that person out there that's, when I say that I don't believe an object can spin and also be in orbit, he's saying, well, we see Jupiter is spinning and it's in orbit, and you could see it spinning, and it appears to be spinning. First of all, most of Jupiter is a big, giant, gaseous, plasma type planet made up of gas. And second of all, it's like I said, the universe is fueling the sun, and it has sort of like it has huge transformers right before it gets that electric power gets from the universe to the sun. Jupiter is one of the last stops in that circuit, and anyway, there's huge Birkeland currents going through Jupiter, a lot more than the sun, than the Earth, and the magnetic field is much greater as well. And Don Scott shows how explains how the Birkeland currents actually go through planets in concentric shells, and the concentric shells go in different directions. The currents go in different directions of the shells. Positive ions going one way down the pole, and you have the negative electrons going the other way up the pole. And because they're going in different directions, you're getting different magnetic spheres that align themselves along that pole. And say that it's like chocolate and vanilla donuts, where the chocolate donuts are going in one direction, and the vanilla donuts are going in the opposite direction. And it looks like a bunch of donuts going in different directions. And the magnetic spheres are attracting elements and particles and dust and things, and making it cloudy and dusty, and you can see the entire donuts spinning in different directions. So it appears to be spinning, but it's not. The inner core is not spinning. So it's best explained that way, and in that way, the Jupiter isn't spinning, but the magnetic sphere is. Okay, so I just wanted to point that out for that person out there that's upset that he knows that Jupiter is spinning, but he really doesn't know, and that's a good explanation, I think. Okay, moving on. What about experiments that prove one way or another? By the way, there was an electrical engineer that his name is Ellendorf. His last name was Ellendorf, and he put his money where his mouth was, and then he promised anybody that was able to prove that the Earth moved or spun on its axis or moved in orbit, he was going to pay them a handsome reward. I think the lowest was $1,000 each, and the highest was $5,000. Maybe it was $10,000 each. I don't know, but it fluctuated the amount of reward, I guess, depending on how much money he had. But nobody, and a lot of scientists heard it. And they were challenged by it, and they thought that they could do it, but none of them came up with anything where they could collect the reward. Now, part of the deal was, it had to be proven, and not just theorized, and not just rationalized, and not just Like I said, it had to be proven. Now, as far as proof goes, in the late 1800s and early 1900s, in turn of the 20th century, is a lot of information. Again, now information is started to explode then. The information explosion that we're in now, it's tremendous right now. But the information explosion started back in those days, in the late 1800s, and scientists were going into greater and greater debates and collecting information about thoughts and things, and and the heliocentric model was started to become challenged. And the scientists of the day, well, they said, let's put the whole thing to rest, and we'll prove that the heliocentric model is correct. So there were a bunch of different types of experiments done, but what comes to my mind, two of them come to my mind. One is Airy. Actually, it wasn't even his idea, but he decided to do something that was proposed a number of years earlier, and everybody agreed that it would be a good experiment, but nobody wanted to do it. But the idea was to look at a star through a telescope and see whether or not it moves. And you would know if the star was moving, then the light would shift on the bottom of the telescope, and it would be even more pronounced if you filled the telescope with water, and therefore you would get that you would get a much slower speed through the water, and therefore a much and therefore the distance per time would be greater in the light bend, the light shifting. That's basically the idea, and guess what? The results of that experiment was the Earth does not spin, does not move. And there was another one at around the same time. It was called the Michelson-Morley experiment. And the idea of that one was that light was going to come in and go in the direction of the Earth's moving, in the direction of the motion of the Earth, in one sense, and the other sense was going to not have that. So the idea is that you have there's a split beam in there, and the split beam splits the two paths and has light coming in two paths. So the same exact stream of light gets split. One path goes with the direction of the Earth, the other one goes against the direction of the Earth, and there should be a nice, handsome shift in there should be a change in the fringe pattern of a detector that would detect such differences in light speed. And it did not prove to have any significant motion of the Earth. It proved the opposite. Okay? So here we have everybody scratching their heads saying, how could that be? That means that the Earth doesn't move? Now, I don't know why they're asking that question, and it doesn't appear that the Earth moves. What was really the objection? And the objection was, well, they don't want Genesis to be right. Now, all along now, Genesis is wrong. I mean, according to cosmology book, Genesis is wrong, and the cosmology book is right. And if you're telling them that the Earth doesn't spin, then they get upset. That's exactly what happens. They get upset. If you look at what the mathematics of the speed of light and the speed of the Earth, if you look at the math of it, you have the speed of light plus the speed of light that's coming in towards the Earth, plus the speed of the Earth coming towards the light they would be meeting each other. There'd be an increase in speed because the Earth would be hitting that light faster and the light that's coming from the other side is going to be hitting the Earth slower. So there's a little mathematical equation here. You see in this diagram. This is Dr. Philip Stott, Stott, and this particular video is, I think I got my biggest kickstart in my changing my thought patterns after I watched this video. It's an excellent video. It's 2 hours long, and you get a common sense guy telling you common sense reasons why the academic media are not so common sense. Let me interject here that there's another common sense guy out there on YouTube. His name is Malcolm Bowden, and I got a lot of this kind of information explained. He's got the gift of making something simple and easy to understand. Malcolm Bowden. But this formula that Philip Stott has here is common sense. I mean, if it was moving with the velocity v, that c plus v had to be greater than c, and c would also have to be greater than c minus v. Everybody would say, yeah, that's true. But guess what? Michelson-Morley came along and proved something like that, so we're going to have to disprove it. We had to throw out his results because it doesn't fit our thinking. How do we do it? Well, we get a guy like Einstein that comes up with and again, Einstein really did not come up with the theory of relativity. That was done by a guy named Lorentz. Lorentz contraction and Lorentz changing of the clocks changing in speed and everything relative. That whole idea about being relative, time, clocks being relative, and all of that, observances are relative, and all of that came from Lorentz, and it didn't. What he said wasn't fully able to throw this Michelson-Morley experiment out. So what Einstein does is, instead of the clocks changing, he has time changing, space and time changing. Okay, space and time changing. And in this special theory of relativity, you cannot have anything going faster than the speed of light. So therefore, c plus v just looks like it's c plus v, but really that's equal to c. And c minus v looks like it's c minus v, but really it's still c. So in all cases, C plus V is equal to C, and therefore Michelson-Morley is trying to find out that if that's true or not, and it doesn't seem to be true. It seems like either way you go, it still comes out to be the same, and Einstein says that's the reason why. Everything is relative. And they throw the experiment out. They throw the results out, and they go on and on and on with heliocentric model. Okay? Now, there were a couple of guys that didn't agree with that, and Sagnac, his name was Sagnac. And what he did was he had a similar idea, a similar situation that Michelson Morley came up with. Um, and in this case, what he did was he rotated the whole mirror. And he was just trying to see if it was true that C plus V equals C minus V. And he was doing that. So he was having the Earth, the table spin, right? And he splits the beam and everything. And he has one test beam that's just plain speed of light, one beam going in the opposite direction of the table, and the other beam going with the direction of the table, and the table spinning at a pretty rapid rate to get a regular difference in fringe shifts. And guess what? Guess what's the answer to that one? They get a faster beam of light, they get the speed of light, and they get a slower speed of light. Just like it is expected in the way which looks normal to us. So he disproves Einstein. And guess what? So we're not going to talk about this. You guys just wasted your time because we're not even going to listen to you. Because nobody did listen to them. They just kept right on as if this experiment did not prove Einstein to be wrong with that special relativity thing. That's the way it goes. And I know that nobody's going to listen to me either. They didn't listen to them. They don't listen to Philip Stott, Malcolm Bowden. They don't listen to Gerard Bow. Okay, now and who else? Who else is very prominent? And Wallace Thornhill and Don Scott with the Electric Universe. They're not listening to those guys either. And I think it's because they like the sun so much, they don't want it to not be a fission reactor in its core. They like it. They like that sun. They worship that sun. And that's why they want that sun in the center. That's one of the reasons. And the main reason is they don't like the book telling us that the sun is made as a light for us to heat the earth, to heat the people on the earth, to heat us. We are made in his image. They don't like that. But they're going to have to, we're going to let God take care of those people. I'm not going to say what happens to them. Let them figure it out. Now, one of the so-called proofs from the heliocentric camp is that of stellar parallax, and that's the idea where an object that's closer to you from one eye will seem to move, and you can do that with your thumb in front of your eyes, and then you close one eye and you close the other, and it appears to go back and forth, and really you are moving, you are looking at a distance, and that's from one eye to the other. That distance is now seeing the same object, and it looks like that object is moving. Look like so there's a distance, but if you stick your hand way out there and you do that, and if you look at a distance look at something in the distance, you don't get that parallax effect as much. It goes weaker and weaker. So the closer the star is, the more of a pronounced parallax distance between the same object is going to look if you go from one point of view to the other point of view. Now, Tycho Brahe was a pretty good astronomer back in the he died around 1600. He was poisoned, by the way, and they took all his information, just to let you know. 55, he died at 55. But they were trying to convince him to believe in the heliocentric way of doing things. And he accepted everything, but the stellar parallax is what he couldn't accept it because of stellar parallax. Now, we have a certain amount of stellar parallax out there, but it's very, very small, very small. And there's only a handful of stars that actually have enough pronounced stellar parallax to make a measurement. Okay? And Tycho Brahe, I don't even know if he knew of any of them, but because they're so small. The ones that we do see, the little stellar parallax that we do see, can be explained. Again, both models can explain it. And Tycho Brahe did not really see because just think about it. You're seeing the object in the summertime, and then your other eyeball is 186 million miles away in the wintertime. Okay? There's a big difference in the eyeballs. All right? There's a little bit of a difference in the eyeballs on the Earth, but there's a big difference in the heliocentric view. Tycho Brahe did not see that. Now, he knew the stars pretty good, and he couldn't see. He knew that did not happen. So he always stuck with the geocentric model. Now, so what does that have to do with us? Well, what it has to do with us is those few stars that they see that do have a little bit of a parallax, they use the base in the formula for measuring the distance to that star, which is a simple geometric calculation, and I'm going to go through that, changing the dimensions of the base to the geocentric model. Now, the star. Let's take an example here. The star for Proxima Centauri in the Centaur constellation, I would assume, has the biggest the biggest distance in the stellar parallax effect. Everything else is a much smaller angle than what this one has, and this one is 0.772 arc seconds. Okay, so now if you take that as the known angle, the tangent of 0.772 arc seconds is equal to the opposite, which is in this case Tropic of Cancer to Tropic of Capricorn distance. All right, not 186 million miles. We're going down to 5,260 kilometers. That's the difference that we know from winter to summer. Okay, and we divide that by the adjacent, which in this case is the distance to Proxima Centauri, and we get for the tangent of that arc of 0.772 arc seconds, we get 0.0000374,276. Pretty small number, but actually the smaller this number, the bigger the distance, because it's equal to the side opposite, which is 5,260 kilometers, divided by the adjacent. And that would mean that the adjacent is 5,260 kilometers divided by that big, long number with all those zeros and beginning with a 3. And that gives you, it's 1,405,379,986 kilometers. Okay? Now, 149.6 million kilometers is distance to the sun. So it's basically the distance. So this way, the distance to Proxima Centauri, the nearest star, is only 10 times further than this distance to the sun. And the sun takes 500 light seconds or 8 minutes, 20 seconds to get to us. And now this star here takes 4,683 light seconds, or 78 minutes, or about 78 minutes to get to us. And that's a big difference than what they have, because they say it takes 4.22 light years to get to us, which is 28,456 times further away. Okay, so that's what I'm saying. I'm saying that if you take away the heliocentric model and you don't go by it, then you can't have this humongous stellar paradox, which begins the closest star pretty freaking far away. So when you calculate stellar parallax with heliocentric model, you're in this, at least in this example, you get 28,500 times further than what you get if the Earth does not spin. So is it important? Who cares? Well, who cares comes to how far away they are. And don't forget, this 4.22 light years away is the closest one, and they're telling you that the furthest one is 14.5 billion light years away. Billion. So, and they're getting that based off of Doppler redshift, and the Doppler redshift is dead as far as I'm concerned. They proved it dead. I mean, Holt and Arp has a stellar object that's got a redshift of so much. Connected to it with a filament is another object right next to it, and it's got a completely different redshift, which means it's complete. If it was, the redshift did have something to do with the speed of travel away from us, like they say it is. I mean, that could not happen. Another sword in the heliocentric model enemy, and guess what? It's like you're fighting a robot because he patches it up and he keeps going. Well, he's only going to go He's only going to go so far, and then it's going to time stop. Okay. Yeah. So again, I want to stress how there is this continual fight from the camp of the living God with the living Bible and the living words, and the Ruach HaKodesh, the Holy Spirit, and all that is good in His heart for man and His grace upon us. All of this is a fight of faith against the enemy, and the enemy is got a lot of stronghold in the minds and the hearts of men, and he's got them deceived and disillusioned and in error and in darkness, and men loved the darkness, for their deeds were evil. Okay, this is the battle of the light against the darkness, the truth against the lie, the spirit of goodness against the father of lies. The enemy, Satan. That's exactly what it is. We're in that battle, and this is part of this is actually where the rubber meets the road, because it's either the holy book or it's that cosmology textbook that comes from a man, the mind and the heart and the thought of a man, and behind him there's an evil, deceptive, disgusting spirit against all men of God and against all people of God and against God Himself. So you got to be able to choose what side you're on. As Joshua once said, "As for me and my house, we will serve the Lord." And that is Joshua was a very important guy in a very important time. He was the servant of Moses, and he took over where Moses left off. And where Moses left off was entering into the promised land, and overcoming the people that were in that land, the land of giants, the land of enemies. But God was with them, so therefore they were able to succeed. And in Joshua 10, there was a battle. There were 5 kings of the Amorites. It was at that time, at Jerusalem at that time, had a king of the Amorite. Hebron at that time had an Amorite king. Jarmuth had an Amorite king. Lachish had an Amorite king. Eglon. And all 5 of them went up against this town called Gibeon, because Gibeon was a Canaanite tribe, a town that made peace with Joshua and the children of Israel. So these kings did not like that, and they went up to make war against Gibeon. Now, Gibeon asked for help from Joshua. So Joshua sends from Gilgal and all the people of war with him, and all the mighty men of valor. Okay, now, verse 8 is an important verse to me. And the Lord said to Joshua, "Fear them not, for I have delivered them into your hand, and there shall not a man of them stand before thee." So a reason why I say that verse is important is because it's instilling within Joshua that God is with him. Okay? He knows that God is with him. And so Joshua, verse 9, Joshua come up suddenly and went up from Gilgal all night. So now all night long he's traveling up to Gilgal. And now the Lord is doing some fighting here for them, and the Lord discomfited them before Israel, meaning discomfiting the Amorites. And he slew them with a great slaughter at Gibeon, and chased them along the way that goes up to Beth Horon, and smote them to Azekah and unto Mekkedah. Okay, now, verse 11. And it came to pass, as they fled before Israel, and were going down to Beth Horon, that the Lord cast down great stones from heaven unto them, unto Azekah, and they died. And there were more which died with hailstones than they whom the children of Israel slew with the sword. 12 and 13. Then spake Joshua to the Lord in the day when the Lord delivered up the Amorites before the children of Israel. And he said in the sight of Israel, Sun, S-U-N, stand thou still upon Gibeon, and thou, moon, in the valley of Ajalon. So he wants the moon to stay where it is and not bring on the night, and he wants the sun to stand still over Gibeon and give them light to completely defeat the enemy. And because in verse 8, God is telling Joshua, I'm going to be with you. Joshua knows that God is with him. Joshua knows that God can make the sun stand still, and he can make the moon stay still. And 13, and the sun stood still, and the moon stayed until the people had avenged themselves upon their enemy. Is not this written in the book of Jasher? See, another witness. So the sun stood still in the midst of heaven, and hasted not to go down about a whole day. So, in other words, it's about 12 hours it stayed still up in the sky, and gave the Israelites time to do what he had to do. And 14, and there was no day like that before it or after it, that the Lord hearkened unto the voice of a man, for the Lord fought for Israel. Okay, so now there it is. It's written. It's written in the book of books. It's written in the same, inspired by the same Holy Spirit that inspired that first verse with all those sevens. This is a book that when you know God exists, you believe every single word. As a prophet, as Samuel as a prophet, with every word, he was a precious prophet, because not one of the words which God gave him did he allow to fall to the ground. Now, this is a word that's given to us. It's a history word. It's not a prophetic word. It's what happened. And he says, "Sun, stand still," in the sight of all Israel. So everybody hears him say it. It's not like he's praying in a cave. He's telling the sun. I mean, he's going to look like a fool if it doesn't. But he knows that God is with him. He has the faith that God is with him. This is the whole thing. Faith. You believe it. You believe God. God instills you with, "I am with you." You believe it. And he is with you. He's with you. He died for you. He covered you with, he washed you of your sins with his sacrifice. So he's with you. He's not going to do that for nothing. That is not nothing. And this is not a nothing verse here. This is either true or it's not. Either the sun stood still or it's not. Now, here's where the rubber meets the road, because if the sun stood still and we spin, and the sun goes up and down because we spin, that means the earth had to stop spinning. Okay? That means the earth had to stop spinning. And there's a video. Look at this video. Look. I'm gonna clip the video in here, and you see what happens. What would happen? And this is not too far from what would happen if the earth stood still. Yeah, crazy. Right, exactly. And then on top of that, there's more than the book of Jasher as a witness. Gerard Bow, in his Geocentricity Part 3, he talks about how he requested of the missionaries, in his knowledge of missionaries, and in his travels, and he knew this Joshua verse very well. He's a Christian astronomer, and he knew that something like that, even though this happened about 3,500 years ago, a day that stays twice as long is a notable day. Now, the people in the world of the night, the people in the nighttime, had a night twice as long. Don't forget, the moon stayed still in the Valley of Agen. And missionaries were getting a positive response when they asked the people, native people of the world, different groups in the world, if they remembered anything. And west of Israel, in the Americas and a little bit of Africa, there you see the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There were 11 accounts of a long night, and in the vicinity of Israel, you have 1, 2, 3, 4, 5, and we'll call that one 6. 6 ones that are reporting a long day. Now, this one over here, this in the Australian or Philippine or Polynesian islands or something like that, you notice that it's right in the border of the night, and they are about to go into the nighttime right here, okay? And those people described it as the sun got caught in the grass, or the sun was caught in the net. See, it was going down. The sun was going down, and it got caught in the net. And so it wasn't just written in this book. It wasn't just witnessed by Joshua. And don't forget, he says it in front of everybody, and everybody experiences it. And there wasn't anybody that left Joshua because, he asked for something that didn't happen, and they, couldn't do what they had to do, and God wasn't with them. There was nothing like that. And there was also nothing at all, talking at all in the book of Joshua, or in these people here. Well, it would be in the book of Joshua mostly. Actually the people here, all these people would have said something else Yeah, we all fell. We all, there was a big commotion on the earth. And just talk about the damage and the difference of life if the earth was spinning and then all of a sudden it stopped. So now that's what I'm saying. I'm saying that either this is true, and it is, and all that happened was the sun staying still. That's no big. I mean, that's probably a big deal, but God is God. And when before I knew about geocentricity, I used to believe that verse anyway because God was God. But I like the verse better now, a lot better. Especially you have with these proofs that people talk about, still know it. I mean, you tell your son about that, and then you die, but your son knows it, and he knows the story, and he tells his son. I mean, what else are they going to talk about? So there we have the Book of Books. Now, being that we are talking about the stars and the sun in its heaven, in its firmament, in the heaven that God made for it. And there's a good verse in Daniel 12, and it's verses 2 through 4. And the first verse is the verse that is the most important, okay? The first verse is the most. And many of them that sleep in the dust of the earth shall awake, some to everlasting life, and some to shame and everlasting contempt. I say that's the most important because what's more important, I mean, than your judgment of either to have everlasting life or shame and everlasting contempt? What could be more important than that? In verse 2, the second verse there talks about this topic in a sense, and that stars are made as analogies, and they that be wise shall shine as the brightness of the firmament, as the big, bright, great light that rules the day. And they shall turn many to righteousness as the stars forever and ever. Okay, so stars are analogous to turning to righteousness. Okay, now the third one, but thou, O Daniel, shut up the words and seal the book. I guess sort of like the book that's sealed in Revelation. Even to the time of the end. Now he's talking to the time of the end, and then he has a little colon there. And he says, many shall run to and fro, and knowledge shall be increased. So the time of the end is described as many shall run to and fro, and knowledge shall be increased, which brings us close to the end according to that description. Many are running to and fro. They got planes, trains, and automobiles, and they're running to and fro all over the earth. They're going this way and that way. Sometimes there's a one-way, but then there's got to be a one-way the other way, and they're going to and fro. And nobody can deny that that has increased, and so has knowledge. Remember, we're in the information explosion. Information explosion. You want to know something? It's at the tip of your fingertips. I wanted to know about the tangent of 0.772 arc seconds. I put it in Google search, and boom, it comes up. I didn't, all the trouble I used to have when I look it up in the back, all the trouble that I used to have to do that, now it's at my fingertips. All of this information that I paid good money to get a good education, to get a good physics, bachelor's science physics degree from a pretty good university, SUNY at Stony Brook. I borrowed money to go there. I had to pay it back and all of it is nothing compared to the knowledge I gain now, sitting down at this thing and just thinking about something and getting the answer. Okay, so with all of my thinking and searching and wondering and testing and comparing to get an idea of how the universe looks. Number one, I think it's a huge, huge beach ball, sort of, like a huge, huge, huge beach ball. The Earth is the center, in the center, okay? The foundations of the Earth are all of the gravitational pushes and pulls that keep it in the center, and so it does not move. However, it is surrounded by the celestial lights, including the big guy, which is the sun. I believe that is 93 million miles away, and we should really talk kilometers because everybody else does. And so the way I view the solar system is, as Dr. Gerard Bow posted in his lectures, where the sun orbits the Earth. So the speed that they told you about how fast the Earth goes around the sun, that's the same speed that the sun is going around the Earth. And the sun has all of the planets in the solar system orbiting itself. All right? So the only thing that orbits us, well, and everything is going around us. So in order to for the geocentric model to accommodate all the appearances to the earthbound observer, it has to be in the way the diagram is shown there. Now, you notice that this is called geocentricity, because I'm pointing this out because I did a Google search, an images Google search, of the geocentric solar system, and not one of them had it like this. They didn't have it like this. You see how the sun orbits the Earth there, and all of the rest of the orbits are around the sun in the solar system. And then you have the sphere of the celestial sphere of the stars, which I agree with. That you see how it's thick, but it's a thick line. It's got stars in it, some big ones, some small ones. That's how I view it myself. As you go beyond the solar system, you get into the heavens of the stars themselves, and they are not as far away from each other as you were told. I believe that the moon is as far away as they say it is, and that it has it's the size is what they say it is, and the Earth is round. It's a globe. It's a round globe, and it's the size they say it is, and the mass they say it is, and it has a north and south pole, and the north on the North Pole axis is the star Polaris, and that doesn't move in the sky. It does not rotate around us because it's the top. It's the top one. It has a slight amount of rotation to it, but all of the rest of the stars are in sort of like a thick plasma gook. All right, that is all around, all around the inside of this global, huge universe sphere. All right, and this plasma gook is all in there. Now, when I say plasma, it's composed of gaseous materials like helium and hydrogen, mainly, and also busted up atoms like just ions and electrons. And when those things bust up like that, they go into filaments, electric currents, that permeate the plasma all throughout the whole universe. And they feed each other with electrical energy, and therefore things like Jupiter can emit light like it's been doing, and I think that Jupiter is also feeding the sun, and most of the universe is out there feeding the sun the greater light that rules by day. Okay? The lesser light that rules by night is actually getting fed by reflected light from the sun. And all of the, the lightnings and stuff like that, that's all from the electric plasma, thick jello plasma that's out there. And when I say jello, it's almost like it's held up by jello, but it's held up by the Word of God, which is within the 0 point energy that it has other names. I mean, I'm going to say ether is one of them, and there's a lot of disagreement about what name that is, and dark energy is one of them, and that's a bad name. I think 0 point energy is the best. Dr. Gerard Bow calls it the firmament. Now, I mean, I think it's it's not really a bad word for it, because he called the firmament heaven. He made a firmament in between the waters and the waters, and he called it heaven. Now, before that day, which was the second day, he created the light. Now, the light, you had to have the firmament there to make the light. So I can just let you know that that's really not a strong point. Dr. Bao is excellent, and he knows a lot more than I do. He's been doing this all his life with the telescope. And I agree with most of what's going on out there in the astronomy world, but I do disagree with the heliocentric point of view, and that is that sun is close to us. It's fairly close to us, considering the stars. Now, the nearest star, I believe, is only 10 times further away. It's 10 AUs further away. That's all. Light comes 8 minutes to get to us, and that light comes 78 minutes to get to us. So it's about 10 times further out, the nearest star. And again, the stars are stretched out like a curtain, and the thickness of the curtain, it's thick, but it's not that thick. And that curtain goes completely around in a globe. It's like he stretches them out like a tent, he says. So you have a tent on the northern hemisphere, and you have a tent on the southern hemisphere. That's all. It's stretched out like a tent, and it's really, really thick. And you can see that even the model in the Bible, it has 4 layers in that tent. So that's that tent is like a gel, and it's spinning. It's spinning humongous speeds. It's faster than the sun is going around us, because they're further out in the diameter of the big ball. And the sun is going around us pretty fast. And the moon is going pretty fast. I mean, all those objects out there, you better not get in the way of the man, because they are going. And again, I don't think that there is any object that is orbiting in it with a spin, because of the fact that a gyroscope resists a forward force. It resists a force like that. It wants to go in its own torque direction. It resists gravity. So it's you almost need gravity to have an orbit, and a spinning object resists gravity. So I don't think. I mean, the moon. You can see that the moon doesn't spin. The face of that moon is always in front of you. You don't see the other side, and that's a normal way to orbit. And I think they all orbit like that. Okay, and that plasma material is permeating the entire universe. Again, very, very electric, busted up atoms that have electrical charges that move towards positive charges, and they go in different filaments, and they go in opposite directions, and they sometimes short out. And when they short out, that's called a Z-pinch, and that's when you get another star. Okay? Now, now again, the redshift, I don't believe the redshift is a Doppler shift. I believe it's one of the explanations for the redshift that I noticed was somebody thought of that it has smaller atoms. Okay? Now, I think it's just almost the opposite, where the atoms get bigger, or at least the first electron shell, well, the electron shells get bigger, and therefore the wavelength has to get bigger. Now, when you have this Cepheid galaxy, this Cepheid star, and lots of action, lots of motion, lots of X-ray and gamma ray radiation, you have this hyper energy star. It's the atoms within it, coming out that axis like it does. They are shooting out really, really fast. Okay, and when you shoot out really, really fast, close to the speed of light, now Einstein may have been right about this one thing, if it was Einstein, but it's really not Einstein. It's E equals mc squared, which is not first proposed by Einstein, by the way. E equals mc squared is telling you that you can't, that formula itself tells you can't approach, a mass can't approach the speed of light. Okay, so because it gets bigger, the mass gets bigger as it approaches the speed of light. And so that could be the reason. The reason could be that the nucleus of the atoms are not smaller atoms, but the nucleus of the atoms are getting bigger, which is causing the orbits of the electrons became larger, and so did the wavelength got longer. But meantime, they're both are still being held in check by the 0-point energy, because the protons and the neutrons within the nucleus are surrounded by the 0-point energy, surrounded on all sides, and they're able to force. They're able to become that strong force that physics talks about. And on the same time, the electrons have to stay in their orbit. That has to be a wavelength. It has to be the smallest orbit has to be at least one wavelength of the characteristics of that particular atom. That's why you have different spectrums. You know, a spectrograph of different elements has different wavelengths, and they come out differently. They're not all the same, even though they're all the same as far as just all being atoms. Elements are atoms, but the hydrogen has only one proton, one neutron, one electron. That's hydrogen. One electron, one proton. Helium, 2 protons, 2 electrons. And then you get neutrons in there too. But, so they go on and on and on, and all the periodic table of the elements shows you all of that. But they all are consisting of protons and electrons, and also neutrons. And a neutron is neutral, and so the whole place is electrically balanced. The whole world, the whole universe is electrically balanced with the right amount of each one of them. But sometimes a massive object like a cloud can have too many, either too many positive ions or too many electrons. And when that happens, you get this huge filament of electricity going from one place to the other place, and we see it as going into the earth, and we also see it go from cloud to cloud, lightning. And that lightning is out there, and you see when you see a nebula, that's really plasma gas all around, and the plasma gas is sometimes in its glow mode, sometimes in its almost glow mode, and sometimes in its arc mode. There's three different modes. It's shut off, and then approaching the glow mode, and then in the glow mode, and then in the arc mode. So that's what's out there as well. Different levels of glow in the plasma, and that's what and a different level of energy in the glow is going to give you a different color light, different wave frequency. Okay? Now, so I think that it is an amazing thing, this gigantic globe. This outside skin is I think it's almost like an ice, but it's extremely cold because they measure the temperature of it, and it's zero energy. And in the scripture there, you see that he makes a tabernacle for the sun. And I think that tabernacle for the sun is the universe itself. He's making that tabernacle for the sun on the fourth day. And the stars are helping it to get its energy to create the heat and the light. And I think the sun is the biggest. It's not a medium-sized star. I think it's the biggest star. That's right, because all those other ones are not so big, and they're closer than you think. Okay, that's what makes them look like little tiny stars. When I see a plane, sometimes I see a plane and I gotta wait to see if it's moving. Did I see it moving? Yeah, it is moving, so it's a plane. But I wouldn't know it was a plane if it was just staying still. If it was a silent helicopter with a light on, I wouldn't know that. That's what I'm saying. And if it was a plane, it has a really, really, really small light bulb. But the fact that it's not that far away, it looks like it's just like a star. So the star's got to be a lot bigger than the plane light bulb. But the stars are just light bulbs. They're almost like Christmas tree lights. They're like Christmas tree lights compared to the 150-watt light bulb that you have in your living room. You got there's these little 4-watt light bulbs that surround the Christmas tree, and then you have the 150-watt light bulb that lights up the living room. Okay, so you have different brightnesses, and you see the Christmas tree lights as small, and you see the big one that lights up the living room as bright. Okay, and that's the same thing. He makes a tabernacle for the sun, and if you look at the diagram, you could see how there's a setup it's almost the outline of a huge power supply to supply the sun. And that's what the electric universe is coming out and postulating right now. I agree with them. Knowledge shall be increased. Daniel 12:4. It comes 2 verses after. Many of them that sleep in the dust of the earth shall awake, some to everlasting life, and some to the shame and everlasting contempt. Please, if you hear anything, hear that, because that is the most important thing. That is the most important thing that you should have posted to the top of your head and wrapped around your arms, and making sure that you are aware of that verse. It's much better to go into that judgment on his side rather than rather than what are you going to do? You're going to take that cosmology book and with you, and you're going to say, but it says right here that the stars were. I mean, you say that you said you made it in 6 days, and look what the scientists were telling me. Is that what you're going to do? You're going to say, here's the book. This is what it says in this book, the cosmology textbook. What, are you kidding me? That thing is going to melt. You're not even going to be able to bring it to you. Bring it to them. We won't even be able to bring the Bible. This is an open book test. We got the Bible open book. Study it. Okay. That's about it. That's not about it, but I mean, it goes on, and this thing has to come to a close. Good night, or good day, or happy. Jesus loves you.